Let's start. And welcome to Italian C++ again, conference. Oh, last year I started again to give talks in person. It was, mind-blowing. It's nice to be here again and talking in person to real people instead of cameras. Let me make my chrono here so that I don't go too much further. So I am Raffaele. I am a consultant in various technologies. I mainly talk about .NET stuff, C#, and so on. I am a Microsoft MVP since, oh my God, 20 years. So it's a long, long time. A few weeks ago, I was in Redmond in Microsoft talking with the teams, speaking about this stuff. And also the latest thing that Microsoft did with Visual Studio for Unreal Engine, by the way, because there are a lot of things that has been done from Microsoft itself to provide a better developer experience there. And I am also an electronic engineer, so I enjoy spending a lot of time in my crazy lab with microscope, 3D microscope, soldering in SMDs and doing crazy cards and so on. So digital stuff mainly. And a long time ago, I wrote a book about electronics and physics that is behind that, but that's too much. And then I am also a speaker in various conferences around the world. I mean, I spent a lot of time in many countries. I enjoyed meeting people, discussing technology, and I enjoy this. But let's go straight to the point. There is one important thing in my life, that when I started learning C language, the very first project was a porting of a video game from Amiga to DOS with the EGA, not the VGA, the EGA. That was really a very bad graphics card, so slow. And the PC were super slow as well. And if you tried just to use a single byte in RAM instead of using a register, you can notice the difference in the screen because it was lower. So I could really feel, I mean, you can measure, it's like a huge benchmark, you know. You can see that it's lower. And then the project failed. Not for me, because I was behind just the porting stuff. So I was just coding C and some assembly code, of course. At the time, it was very common. But for other reasons, the commercial stuff failed, and so you will. But there are screenshots on the internet, by the way. That's the graphic guys were amazing. I mean, they did a great job. And there is a huge difference between the role of the game developer today from the game developer at that time. So now, if you want to be a game developer, you don't have to be an expert. You don't have to know almost anything about programming languages, which is mind-blowing, because with Unreal Engine, you can really create everything just with the designers. And that's bad. That's really, really bad. So we will start talking about Unreal Engine and the architecture that is behind it, because if you understand the pieces and the building blocks in Unreal Engine, you will enjoy then the whole environment. Some runtime and fundamentals that are very important. And I also left a few other slides that we will probably will not see here, but I will give you so that you have some tips to bring with you at home, so that you can, make your life easier when you want to try Unreal Engine right after today. I have built a retro game from my times. I used to play at the university in the space between the lessons. And I will show you the project structure in Unreal Engine so that you know at least where is my main, you know at least what to do, what to begin with. And the crazy thing is that if you go to YouTube and so see all the YouTubers talking about Unreal Engine, you will find a huge amount of material that is absolutely, mostly not relevant when you want to do something with C++, at least. Unfortunately, many YouTubers that talks about C++, they really don't know the good parts of C++. They try to do something, they make some hypothesis, and most of them fails. I mean, there are a lot of great people out there, and they are very proficient. I am not saying that they are all bad developers, but the great majority of the material is not relevant. Even in the forums, you read certain articles talking about how the garbage collector works and say, oh, what are you saying? So come on, and that's it. So Unreal Engine is a framework to mostly create 3D games, but nowadays it's also used to create movies. So it's really, you can build a photorealistic stuff. And then what we will not see today is great graphics, because I am a developer, you know, and I mean, developers and graphics does not fit. Like developers and front end, I mean, oh no, I am a backend developer, so please. And I mean, the game engine is entirely written in C++, but in a C++ that we will see that you will not recognize as a C++, because it's very different from your, from what really C++ is. And there are these things that call it blueprints. What are blueprints? Blueprints are classes, okay? So it's a piece of C++ code created by the editor, and you just have to move some mouse and make some click, nothing special. And the machine behind all the generation stuff create the C++ class for you that can inherit either from base classes of Unreal Engine or your own C++ class that you created. And that's very important, because if you create some C++ code and then derive this from the blueprints, you have most of the power with it. Okay, so this is the real point, and we will see this in a minute. As I said, there are many developers that just use blueprints. I mean, that's bad, and the reason is simple, because if you just use the editor, you end up in making several things repetitive. I mean, the same task, you have to repeat it like 1,000 times, because you have 1,000 rocks in your scene. You have to change a lot of attributes by hand, and you click and you scroll down and you have to change the values and so on. If you go with C++, of course, you can automate with code, which is much simpler. Some of the things can be done also with blueprints, but it's a pain. And also it's slower. Why? Because they use reflection. And you say, reflection, garbage collector, what are you saying? We are in C++, not C# or Java. And you will see that in a minute. And the sad news is that you cannot use the STL, the standard library, and cannot be used. So you cannot recycle any code that you will find out there for C++. So forget it. And the reason is that basically Unreal Engine redefined all the primitives from scratch. And they have to manage in a different way. You still can create simple C++ classes, but you are quite limited to the number of standard primitives that you can use. So there are very high limitations about that. There are some of these STL that can be used, but they are exception. So you can safely assume that you cannot use them and forget it. And this is bad. Why? Because there are a lot of algorithms, optimization algorithms, let's say, if you want to go from A to B in an optimized way, you have, thousands of different ways to do it. And there are approved ways, in the mathematical sense terms, that, it's obvious, I will use this algorithm, why should I write it by myself again? No, it doesn't make any sense. And instead you have to, unless you find something in the library from Unreal, which is, probably yes, but I had to write a lot of code because of that. And so that's a bad thing, but that's a fact. I mean, when you deal with blueprints and just run your code, you have a lot of I mean, advantages. But when you end up in having this, that's bad, because you are totally lost. I mean, you don't have any clue where you end up. I mean, there is nothing. My project is blueprint only, so you don't know how this is related. I mean, we know what this is. I mean, I know where to start from with a message like this, but people using just the blueprints, they are lost, okay? So yes, this is a win. Would love some support right now, can find anything about this. I have no idea how C++ works. Oh my God. That's, I mean, more than funny, right? And this is the link, by the way, if you want to see that. Of course, if you have a debugger, you have a stack trace, and you end up in finding the cause very easily. I mean, there is nothing special. It's just one of the many errors. And there is an additional point that is when you have something that is going wrong and you suspect that is the garbage collector, you can suspend it. And this is not something that you can't do in Java or in .NET, okay? But you can suspend it and try again and say, oh, maybe this, if that, it doesn't happen anymore, you know that probably is something related to the garbage collector. So there are tools that are pretty good. And finally, I want to tell you something about the minimal requirements. This machine is very good for business purposes, to use for developing, I mean, .NET backend application, ASP.NET, and so on, but it's so bad for game programming. So forget using a normal laptop. You have to take an RTX NVIDIA card that is very expensive, a lot of gigs of RAM on your GPU, and a lot of RAM on the CPU, and so on. And please, terabytes of things, because the assets are going to make your hard drive crazy, literally crazy. So I had to find some way in order to show you the demo here. And I will explain some some tips and some tricks that I used to make it work on a very constrained PC. And maybe you will want to use that as well. And once you start installing the itCppCon game launcher, this install everything that you need. It's very easy. I don't want to explain that because, I mean, it's straightforward. I strongly suggest you to use the latest 2022 or Visual Studio, because Microsoft created a lot of enhancement. There is in the installer a checkbox on Unreal Engine extensions. And if you install that, you will find that you have a lot of, I mean, facilities in writing the C++ code. And of course, you have to be very patient, because when the shaders are going to be compiled, you will take a long coffee, a Starbucks coffee, not an espresso. Okay, that's it. Okay, and finally, you install a plugin from the Unreal Engine Marketplace, which is called Visual Studio Integration Tools, which makes a little better your developer experience. That said, the other super important thing is source control. If you want to, I mean, use a source control, I mean, everything is good, right? And you can go with Git, for example, right? That's the best choice. But game developers are choosing Perforce, which is for paying. Why? Because the assets are huge. So you have to pay in order to keep your versioning of the binary files. And you can use GitHub as well, but you have to change the git ignore. I will give you the sample code on GitHub for my demo, so you can also take a look on the my git ignore, which is much better because doesn't save all the temporary files, which the standard Unreal Engine git ignore file instead does. And you will end up with the first commit to be out of space, which is weird, I mean. And And then also you can eventually enable the large file support, the LFS, on GitHub, which it works perfectly, but you have to be aware that it will cost you money because, of course, I mean, storage costs, okay? That's it. And so demo time. So I want to, this is the link, is public. A few minutes ago, I made it public. And I want to first show what you obtain when you start running something, okay, which comes with the wizard. And this is very common. Maybe some of you already tried it. I mean, this is the very first person demo that you obtain with Unreal Engine. And everything that you see somehow, it's not photorealistic, right? Because these are shaders. I mean, you see all the floor, the walls, the rocks, and everything there is something that is not shaped and has no materials. But this is not our job. I mean, it's the graphic designer shop. Okay, so you have to let them, I mean, imagine if you, instead of the block, you want, I mean, a car or another person or whatever else. And Unreal Engine provides also the ability to render very easily a human figure. So you end up in having the third person wizard, which is like a human walking, and you can see the arms, I mean, swinging and so on. So it's already done instead in there. But it's not very relevant for us because just a single piece of rock or a human, it doesn't make that difference in order to understand the whole picture, the big picture of how it works. And you have physics, which is very good, okay? And you end up in having something which you can want maybe to control, that is going here, which is the word settings. I can override the physics and I say, oh, I want like negative because go down size, 2000 instead, and 90, 80, 100, 980. And so let's see. Maybe I have to, okay. I have to take control of this. And you see that it's heavier. And instead, if you go like 1000, it's positive. You run and you see that, woo, everything goes up. Okay, but that's not very important. And we don't want to start from here because it's definitely something, I mean, a bit too advanced. I want to start from something that you can understand better. So I will close this one without saving. And I want instead to show you my demo, which is a little bit different. So first of all, you have this scene and you see this point, and we will take a look on it. And I mean, I am a little nostalgic, so I created this Tetric stuff. And let me do some move, because otherwise you cannot see some other features. And you will discover that this trick is very well known. You can drop the stuff. You have the, I mean, the score, and you also have, whoop, the animation for that. But you can also change materials so that instead of having plain colors, you have this textured stuff. And I mean, it's fun. And I want to show you another important thing, that is, if I enlarge this one, you will discover that the real logic of the game is implemented in the text log. You see? Okay? Like the real Tetris in text, okay? And that's the important thing. So you want to first create your logic. You have the business rules. They have to be separate, in a separate class. And you want to implement that so that you know exactly what's happening inside your game. You have rules, you have strict things. And then you use them just to make the special effect, and you can interact with your world, and you can move the blocks and so on. I am not using the I mean, the gravity, I am not using physics or collision here. And the reason why I choose to do that is that Tetris doesn't have a realistic physics in there. I mean, the blocks are going like this. I mean, it's not realistic. They have no velocity. There is no acceleration. There is nothing that is similar to a real world. But if you want to interact with the real world, Unreal Engine has a great emulation of the tape. And you have, I mean, full control over the physics. You can enable on the single rocks whether you want a collision or you want the object to be transparent. Okay, if you want a ghost, there is no physics, and so it can, I mean, be used like that. And the first thing that I want to show you is that we have this style behind that. And these are the lights. Basically, you have the directional light is this one. You have another directional light here. You have the landscape, of course, and the sky atmosphere and the skylight. That is the big one. And you have full control of it. You have to first design something that is, I mean, good for you, okay? And if you have something in 3D with mountains maybe or rocks and things like that, you can put in your scene, and then you have to have something that draws some light, okay? And there is full control on how the light has the jump up and down on the atmosphere, because I mean it simulates the real physics on the Earth, okay? And this is something that is very well explained on the documentation, so I will not spend time on this. It doesn't make sense. But this is a very important step, and there are many videos on YouTubers that explain you how to build a scene, how to put the lights, how to have full control so that you don't have to play too much with it. And if you see, there is the black here is the shadow, and if I move, you can see the shadow on the pieces and on the draw board, okay? This is my game field, let's say, and you can notice the difference. And if you want to change that is super simple. I mean, you don't have to bother too much, okay? The components that you have seen here is that normally with a blueprint, you will begin putting everything inside the editor, like, I mean, the game field itself. So this piece of stuff is something that normally a Unreal Engine developer with the blueprints would put inside the scene directly. And you can do this, but I want to have full control of it. And so I will show you how to make it from C++ code instead, which is something that is more desirable. And you have this other overlay, then when you take some point, for example, or the C++ logo, the heart that is going on, this is the HUD, which is the place with an overlay image that you use in order to superimpose on the game something. For example, if you have some human that is shooting, you want to have the personal score right on him, even if he moves, okay? And the other super important thing is that you have to show, I mean, the camera. I want to also in the selection here. If you want to shape the background, you have a lot of tools here. You can see here the tools. If you go to foliage, for example, you can take some texture and draw and paint the underlying scene with a lot of foliage. And you say, what is the foliage? Okay, you go to the marketplace, download some plugins. It will cost you €0, but a lot of storage, which is like 10 gigabyte, more or less, of a very small thing, like, for example, grass, flowers, or rocks shaped in different things. And they are very photorealistic stuff. And when you apply them you can paint with this tool in order to create a whole environment full of grass that is also moving. You can change the wind, and when you play, you see the grass that is bouncing with the wind. I am not doing this right now here. I tried, but the problem is that I have no GPU. My GPU is not strong enough, and I have no memory in order to support this. I went in blue screen directly, so please. It's an Intel GPU, by the way, so you understand my pain. So, okay. So this is basically the scene. Now we are going to dissect a little bit the thing in the slides, and we will come back on the code. See, this was the original Tetris game. There may be some of you who never seen that. Who never see that? Someone, okay. That was fun. I mean, pure ASCII text, and it was crazy. The main Unreal Engine classes are the game instance. Is something that has the longest lifetime. If you have to keep something for the entire length of the game, you should create a game instance. If you don't provide one with C++, there is a base object class that does basically nothing. But if you want to keep something for the entire, I mean, process-wide, okay, for the entire duration of the process, this is the right object. The game mode is very important because it is something that contains the base object that you want to handle, okay? They store players, spectators, or if you want to, you know that Unreal Engine can also make online games, so you have either spectators or the other characters playing with you, okay? And you have here the rules to spawn new actors. With actors is something that is used to represent anything that is in the scene. It's not necessarily human. It can be a rock or a mountain or a tree or something else, okay? You have the ability to pause and resume the game from the game mode, and the transition between levels if you have any. The game state is something that represents the state of the current game, which is exchanged in online games with the server, of course, okay? And provide the facilities to join when other players are there, and is the base class for I mean, the game mode. And the player state instead is the state of the current player. Quindi each player has a specific player state. And the player controller is very important because it is the one that gives you access to the mouse, to the joystick, to the virtual reality and stuff, okay, with the Oculus, for example, or the keyboard, or whatever else you want to use to do the thing. The pawn is a special actor which normally represents the main character and the characters that are actively doing something in the scene, okay? If you have a shooting character that is doing something, typically either you use the pawn or the character itself. And finally, the HUD, which displays the score, which I showed before. And for this game, I created the game field. The game field is the scoreboard that you have, I mean, in the place where the pieces are falling down. And in this case, this is a central actor. Why? Because you have to fix the camera to something. Otherwise, you cannot leave the camera in the world and say, oh, I want my camera there. You cannot do that. It's always tied to something. And the first time that I did it, I made a mistake. It was so funny because I played the game and I see something, and then suddenly everything was black. I said, what's happening there? And I was playing the camera, and I, again, play, and ooh, there is light, and boom, black. What's happening there? And I didn't tie the arm of the camera to anything. And so the camera was subject to the gravity, and it was falling down. I mean, my wife found me laughing as crazy because I couldn't understand that physics applies to everything there. Okay, if you enable physics, you suddenly discover that your pieces are falling down in the infinite space. I mean, it's super crazy. So, what is my main? The main, you can find it in the game mode, because basically, from the world settings, you tell what is your game mode. For example, in our example here, you will find here, I don't know if you can see that because I cannot zoom in this moment. This is a blueprint, which is a naming convention that you will find on the documentation of Unreal Engine, BP underscore Tetris game mode. And right down, you will find others. This is the default pawn class is the BP underscore game field. So the center block blue that you have seen, this is the default pawn. Why is the default pawn? Because of the camera. So I decided to create this board, and I tied the camera on with an arm to the score, to the board, so that I have fixed the camera there. Because if I fixed the camera on the pieces, you will see the board scrolling down, and it will be like crazy, right? And the HUD for the scores, and then the player controller, so that I can use the keyboard on my PC, and the game state, and so on. So everything is on this side. And you remember that world settings are this little window, okay? And basically, what you obtain is that once you have prepared everything, you will get notified inside the game mode, and it will call the begin play. The begin play is basically in the game mode your main, because it's the first opportunity to have something that runs in it. And if you want, for each actor, you can turn it on the tick, which is a periodical tick that you get called in order to do something. And you basically, in many games, not in all, but in many games, you want to leverage either the tick or timers, because are the two things that you can do periodically in your game to do something. On the Tetris, the timers are very important, because you periodically have things falling down, you have animations, you have a lot of things happening, right? Okay. And so let's go back to the project. Once you have created your project, everything is driven by this editor. Visual Studio is even the VCX is not something that you created, it's something that has been created by Unreal Engine. So you, paradoxically, you will never save on the source control your project files, which is, I mean, it's crazy, you know, right? And if you look at, I mean, on the Tetris here, right-click, you will discover that you have generate Visual Studio projects. And I right-clicked the U project. So the most important one is the U project, is not the Tetris SLN, and is not everything that is inside the intermediate is something that is related to Visual Studio. You also have the project files. They are here, and they are in the intermediate folder that you should not save on your source control. They do not care. And also you can notice that the UF5 VCX is almost 400 megs, okay, which is totally crazy. And if you try to save this on GitHub, you will discover that it won't be saved because the maximum is 200 megabytes. Okay, so don't do it. And once you have that, you have this solution that is made of two projects. The first one is a mix of the engine and the editor itself, okay, which are the sources for this. And currently, this is running under the debugger. So everything that you are doing, even in the blueprints, if you, for example, want to intercept a change of value from the editor from 1 to 5, and something that is being set inside your class, you will receive the breakpoint, and it works, okay? And the other, of course, is your game. And everything that is C++ related is subdivided between this private and public. This is a convention that they use, and that I strongly suggest you to follow that, because you will have your life easier. If you want to see what happens, basically we are taking a look. I'm sorry that the projector is not that good, but I cannot do anything else to improve that. I can maybe maximize a little bit this. And these are the so-called, these are the classes that has been created. You have many ways to create it. Probably the easiest one is to right-click here and make a new C++ class, and then choose your base class. Okay. And we are coming to an important decision. So I create a new class. If you want a game mode, of course, you have to derive from a game mode. If you want an actor, you have to derive from actor, okay? And that's easy. But if I have something that I want to keep, for example, all the parameters that I structured in order to do something in my logic, what should I do? And my suggestion is to use the U object, which is the base class for every object in the field. And this, you will find it going in all classes. This is object, which doesn't have the U as prefix, because U is a naming convention, so it's always added automatically to either your classes or the library that is inside. So this is in reality the U object. And I want to show you what happened when I created this. So this block manager, we want to see is in reality a U blocks manager and derives from U object. And has these strange things here. I have this include, which I didn't write, but contains a lot of code. And you can see that there is a huge number of declarations you should never touch. Why? Okay, let's see it. When you use Unreal Engine, you are in reality using C# or Java. Pick your choice. Okay, that's not C++ anymore. You have garbage collection, you have reflection, okay, and you have a lot of things, facilities that resembles these other languages. And we have said before that we cannot use STL even, okay, because the STL does not provide the facilities to keep trace in the garbage collector of what is happening to the chain of references, okay? And so these two key features are very important. You can imagine why is important having a garbage collector in a game. So everyone told me in the past that garbage collection is crap because bring my performance down. This is not true, absolutely. And if you look at the classic, the stereotype of the gamer is the classic American fat boy being in 48 hours with the controllers and eating pizza with Coca-Cola, okay? That's the stereotype. And what happens to this guy? It happens that he will receive an out of memory in his console. Why? Because there is no more contiguous memory. There is no leak, guys. The garbage collector is not a problem of leaking. It's a problem of having contiguous memory allocated, okay? And if you don't have a continuous memory, your STD vector or your TRA in terms of your Unreal Engine will not find a piece where to put these blocks of memory, okay? So you have to compact it. And also, if you don't have continuous memory, you cannot take it down on your L2 cache easily. So you have to do a lot of things in order to manage it. And will result in being slower. And so everything that is deriving from U object and doing some strange things goes in the garbage collection. And the garbage collection registered all the U object related stuff, so even the actors and all the stuff, with the add to root. And once you are there, you finally have participate in that. You still can use standard C++ classes without deriving anything. The problem is that you have to be in control of how managing the pointers, and you will not have the standard pointers and the smart pointers in order to manage it. So if they have a short lifetime, that's fine, it means there is no problem. But if it's something that you want to keep for a long time, it's much more difficult. You will find that creating a new object is much easier. Okay. And also, if you want to use an Unreal Engine container of pointers of your type, you have to use the UObject, because otherwise they cannot manage something that is allocated the old way with the new. Okay. And participating to the GC and reflection is something that is, exposed with the Unreal Engine. So what we have seen in C++ before is explained here. So we have a preprocessor tool that creates this generated class. We have the macro with a uClass that you can use to participate to the reflection. There are type definition like super colon that is basically a type def for the base class. And you have to abandon new and delete and use new object, okay? There is a strange thing that you also have to use destroy to destroy the actors. We will talk a little bit later. And there is also the class default object. What is that? Basically, you still have the constructor, the standard constructor, and that is called, of course. When you want to have the default values for your classes, you write it down either in the .h, directly on a segment of the field, or inside the constructor. Those are considered the default values that you will find back in the class default object. As soon as the game starts, the blueprints that derive from your class is merged there, and they will deserialize the value into the instance that you are using, overwriting eventually the default value of the constructor. So you have two different set of values. The default one that are the standards, the one that you always use with C++, and the one that are deserialized from the blueprints that derives from your object. And that way you have control on the values on the instances. And I leave the rest for your. These macros and specifiers are well explained here. I will not spend much time. Basically, it means that every time that you need to participate in reflection, you have to tag either the class or the function or a field and let it become a property or a function available on the blueprints. For example, if you want to expose to the blueprints in the editor of the blueprints a function called add, okay, that you have to mark it with uProperty. uFunction. And if you want to have a field that can be used and you can type in the editor with, a number of lives, okay, and you're 5, you have to mark it with uProperty. And I want to show you how this is done here. And basically, this class is the one, the blocks manager, by the way, is the class with the logic. So it doesn't have much that have to participate to the Unreal Engine. You can see which is basically a standard class. Instead, we have the item base, which is the base class that I used for each block. So the blocks that are falling down. And these are the U class, for example, which is an actor. You see the generated body and all this stuff. And you can see, for example, that there is a primary material, secondary material, and extra material here. And these are the places that you will find back when you go to the editor and open one of the blocks. You say blueprints. I created this by creating new blueprint class, and then I picked my C++ class that we have seen before. So it's super easy. And let's say the block O, for example, the 4 blocks. And you can see that is use the material blue. and the secondary material is the textured blue. Okay, so this is possible. This does not exist. You see Tetris shape. This does not exist in Unreal. It's something that I created and let them appear there so that you can, customize the behavior in this. And this is very good to do because you have now the power to change the material from your code, but you also did not lose the ability to play with the blueprints, which give you the best of the two worlds, okay? And if we go to the item base, for example, you will discover that I have a lot of code and also the apply material. And this is how I decide to apply the material. So I basically received the uMaterial interface star, which I assigned from the editor. And as soon as I call this, I have the possibility to iterate all the pieces of the blocks. You see DL as like 4 blocks, okay? And I decide to apply the material, the specific material there, okay? And finally, what I am doing is I want to get all the child actors, and if they are empty, I do this stuff. Otherwise, I use, you see the ranges, and I get the actor star, and then I apply the material, which is a base method for that. Which is, pretty comfortable to use that. Another thing that I did, of course, is playing with the materials, and you can see it here. For example, the standard blue is very simple, just a color. But if you go to the, let's go, this is a metallic blue, for example. I probably misspelled that. Oh, this one is with the texture, and you see texture sample, which is quite different. Then there are many others, okay? So you have all the materials there. There is the metallic effect, cannot be rendered by my GPU, by the way, but is, very shiny, it's very nice. You have to be very careful because if you have no sky, the reflection of the material is black. So you will see everything that is black, because it's like being in space, right? You don't have reflections. That's crazy. And you have all of this. And finally, we can go to the game field with orchestrate everything. And the most important thing is that I want to compose in C++ the way the main components are there. Basically, it means that every time you put something in the scene, you have the possibility either with the editor, but I wanted to show you with C++, how to compose the components that are part of the orchestration. And each of these actors has a number of components that can decide how the scene has been built. And in this case, I have this root component, which is made of a mesh. The mesh is a shape, basically, that I built using the editor. And you see the board have these pieces. And then the ARM component for the camera, and finally the camera. And once I have done that, I have the camera, and I let the designer decide the distance of the camera, so the length of the arm, for example, or how much is wide the camera lens, and so on. So I can, of course, decide all of that. If you want to make some special effects, then when the user wins, you want to zoom in and then zoom out, for example. You just take controls of these objects and you are done. And you will find that it is quite easy to do that. We don't have time to show all of that, of course, but it's basically very easy. And also another important thing is that when you are in trouble, you can just use these primitives on Unreal Engine, that is draw debug cylinders or do directional arrow. And yeah, I lost my 0 point. I don't know in my world where is the origin. I don't know where is the origin of an actor. So I want to rotate it, but I don't know where it is. And you can just draw arrows so that you can find the 3D space and you say, oh, yes, now I get where these are and so on. So it's that. If you want to see in action this stuff, you just reach me later and I can show you, because I mean, there is not enough time. We are almost done. And I quickly go back here. And what you will find inside what you will find inside the slides are just a memo of the other thing that you can do with C++ in an Unreal Engine. And basically you have these actors that we talked about, the components like the camera length, and the meshes. The meshes are the pieces of rock, the shapes that you want to use. If you just, for example, enable the checkbox, enable collision, you can discover that you can put something over it and they will not fall and they cannot trespass. Okay, so it's extremely easy and not something that is worth wasting time there. And a few reminders, just to create an actor, you have spawn actor and either with the template or with a class, and destroy. The destroy exists for actors, even if there is the garbage collection, just because otherwise they will never be dropped, because the kind of circular reference there. So the actors are always in the scene. So if you want an actor to die, you have to explicitly call destroy, and they will be removed from the garbage collector and moved from the scene. So this is the reason why. And then, of course, you have a huge number of primitives. These are just an example. Otherwise, I could put 1,000 slides. There is no way. I have to stop here, but as I said, I added these other slides that you will discover in my slide deck. They are how to use timers, how to use delegates, how to use primitives in the libraries, and so on, and other tips on the installation, just because I know that is super hard to figure out how to do the things, and they are the first, things that I asked myself when I started with an Unreal Engine. So I hope that to have give you just a glimpse of what kind of world is this, but of course you will have a lot of questions. So if you want to reach me after, because I imagine that the coffee is more important than making questions. So thank you, everybody, for being here.